Heyo, welcome back to another adventure into mathematics with Mr. Marcus. We're going to go all the way back to the beginning now. Exponent laws, product property. If you can remember some of the exponent laws from the beginning of this, will help you, but we'll review them anyway. So the product property is an exponent law that requires there to be multiplication of two expressions with exponents like what you see right here. When there is, you can simply keep the base number, that's the big yellow number right there, 5 to the 4th times 5 to the 7th. So you're going to keep the 5, as you can see I'm highlighting really slowly right there, and you're going to add the exponents together. Those are little green numbers on the top right of each of the 5s. You add the 4 and the 7 and you get 11. So you're keeping the base, you're adding the exponents. So let's do some examples. In the first one, we're going to look for a base number. That's the large number that is before the power. In this case, the bases are 4. Since the bases are the same and it's a multiplication problem, we can add the exponents. 5 plus 4 is 9. So we're keeping the base, which is 4, and the exponent becomes 9. Disappear. Good. Now we go to the second one. We're going to look, are the bases the same? In this question, we have the bases which are 4 again, and the exponents are 5. You're going to keep the base number 4, add the two exponent numbers, which are 5 plus 5, which is 10, and we get 4 to the 10th power. And now you should disappear. Thank you. In the third example, if it is a multiplication problem where the bases, that's the large number that comes before the exponent, are the same, like this one, 120 is the base for both, we can keep the base and add the exponents. 4 plus 2 is 6, so our answer should be 120 to the 6th power. You don't have to go any further than that. This is a shortcut using exponent laws. I hate that it's going a little quick, but most of you should remember this from earlier in the 2019-20 school year, so it's not new. 12 is the base, 4 and 8 are the exponents. Because it's a multiplication problem with the same base, we can keep the base 12, add the exponents. 4 plus 8 is 12, and we get 12 to the 12th power. Disappear. Next one. If the bases are the same and it's multiplication, we can keep the base and add the exponents. Here the bases are the same. One of them appears not to have an exponent. If it appears not to have an exponent, it means it must be raised to the power of 1. So when we add the 2 and the 1 that we know has to be there, we get 3. It can't be a 0, and you're going to see that in an upcoming example. Maybe right now? No, not yet. Okay, here 2.4 is the base number. 10 and 2 are the exponents. So 2.4 stays, 10 plus 2 gets us 12, and 2.4 to the 12th power is going to be our answer. Pause if you need to. Take notes if you need to. So number 7. In number 7, we're going to look, are the bases the same? Yes, they are. Now here's our example of when the exponent is 0. You should remember when the exponent is 0, the whole value of 11 to the 0 is 1. Which means 11 to the 7 times 1 stays 11 to the 7th, or 7 plus 0 is 7. So that gets us the answer too. Okay, I know it's a little repetitive, but hopefully by the end of this you'll have no problem doing the assignment. 11 to the 14 times 11 to the 14th. This time the exponent and the base is the same, but right now we're only working with what if the base is the same. Keep the base, add the exponents. Keep the 11, 14 plus 14 is 28. Boom, just like that. Number 9. Number 9, we should have another example of where the bases are the same and it's a multiplication problem. So 22 to the 21st power times 22 to the 11th power. The bases are the same. They're both 22. So we can add 21 plus 11, which is 32. And our final answer is 22 to the 32nd power. Next one's number 10. The product property we're working with today states that when expressions with exponents are being multiplied, if they have the same base, we can keep the base and add the exponents. So here we're going to keep the 20, we're going to add 21 plus 12, and that's going to get us 33. So our final answer is 20 to the 33rd power. Next question up, number 11. Should have something to do with the product property. I know it may seem a little redundant that I keep repeating it, but just so we know. Are the bases the same? Yes, they're both b. What is w and y? I don't know, but I do know if I add them, I get the answer. Now, I can't add w plus y, so I just write b to the w plus y. Okay, these red ones are going to involve signed numbers. This is nothing new to us, but it is just going to take it up slightly a notch so that we know it can involve signed numbers also. Again, the bases are the same, and the exponents can be added. Wow, that noise is mad annoying. So we're going to keep the base 10, add the -3 plus -3, and get -6. In this next question, again, we're going to have signed numbers involved, but that's not going to take away the fact that we're still using the same property. Product property says the bases of -5 are the same. We have to add -5 plus 15. I really hope that's not as annoying for you as it is for me with these headphones in. -5 plus 15 is 10. Because when the signs are different and you're adding, you really find the difference between the number and give the sign of the greater absolute value to the answer. So here's another question like that. The bases are the same, which is 5. So now we're going to add -2 plus 9. To add -2 plus 9, you find the difference between 9 and 2, which is 7. And since the 9 had the greater absolute value, the answer is +7. 5 to the +7th power. Okay, if you have to review the signed number rules for adding, feel free to do that. Or, calculators work too. So now here we have 13 as the base, -2 and +2 as the exponents. When we add them, because they are opposites, they're going to equal 0. And anything to the 0 power is the same as 1. So not 13 to the first power, but just 1. Some of you are going to remember exactly why that is. If you don't, feel free to look it up. Okay, if you still have your notebooks and your notes from earlier in the school year, hey, it's there. So here we have the same base again. 14 is our base, -1 and 11 are our exponents. Because they have different signs, we're going to find the difference between 1 and 11, which is 10, and it's going to be +10 because 11 had the greater absolute value. Going to the next one, number 17. Again, we're going to be looking for, are the bases the same? They are. -9 and -9 are the same. So now we've got to keep that -9 and add the exponents. -2 plus -11 is -13. The rule for adding negatives is if they're both negative, just add them and keep them negative. Okay, so I hope that worked for some of you, all of you, as far as using the product property to multiply expressions that have the same base, where we're just going to keep the base and add the exponents. Good luck on your quiz today, and looking forward to talking to you guys again tomorrow.